Hi everyone, in this video we will briefly go over some common applications of double integrals, most of which come from physics. The first one is finding the center of mass of an object. So what is the center of mass of an object? It's basically, so if you have some shape like this, you can identify a point where you can imagine all the mass is at this point. Which means that if you were trying to approximate this actual object by a point mass, what is called a point mass in physics, then the center of mass is ideally the location where you would assume that the mass is centered. For symmetrical figures like a circle, the center of mass would be the center of the circle if the mass is uniformly distributed. But if you have a circle, the shape is circle, but suppose like one half of this is made up of a denser material than the second half, something like this, then the center of mass would not necessarily be at the center, but it will be a little bit shifted, right? So if there's a gradient mass. So the center of mass depends on the density function. It depends on how the density of the object changes over its distribution. So the notation for the center mass coordinate system, so if the density is given by rho xy, then the x-coordinate of the center of mass is given by 1 over m, which is the mass of the entire object, divided by x times rho xy dA, which is where rho is the density function, and y bar, which is the y-coordinate of the center mass, is given by y times the rho xy dA, where mass itself is given by the double integral of the density function, which is exactly all the double integrals we have been finding so far can be thought of as an abstract way of finding mass, where the function itself, f of xy, that we were seeing, can be thought of as the density function for distribution of mass. Let's look at an example. Find the center of mass of this triangular lamina, which has vertices at 0, 0, 1, 0, 0, 2, and whose density function is given by 1 plus 3x plus y. The first step here is we need the mass. So finding the mass is finding the double integral of the density function, which is 1 plus 3x plus y along this region. So now we don't have the equation, which means we got to find out where this is located. So we have a 0, 0, we have a 1, 0, and we have a 0, 2. So we have a triangle here, and it has some mass, made up of some material, and the density of that material changes with different values of x and y. So for example, at 0, 0, the density is 1, things like that. So we need an equation of this line. So equation of this line, we will need the slope. The slope is 2 minus 0, 0 minus 1, negative 2. So the equation is y minus 2 is negative 2x minus 0, or y equals 2 minus 2x. So this y goes from 0 to 2 minus 2x, and x goes from 0 to 1. This is a simple integral. We get a y plus a 3xy plus a, actually, should take less space, y squared over 2 from 0 to 2 minus 2x, which becomes 2 minus 2x plus 3x 2 minus 2x plus 1 half 2 minus 2x squared. There's also a dx involved with this, from 0 to 1. So this will require some algebra, which I'll do here on the side. So I have 2 minus 2x plus 6x minus 6x squared plus, if I factor out a 2 and I square it, it becomes 4. 4 divided by 2 is 2, and I'm left with 1 plus x squared minus 2x. These two combine, so 2 plus 4x minus 6x squared plus 2 plus 2x squared minus 4x. Negative 4x is cancelled. we get a 4 minus 4x squared. So factoring out a 4, this is simply 1 minus x squared dx, which is 4x minus x cubed over 3, 0 to 1, which is 4, times 2/3, which is 8 over 3. So the mass is 8 over 3. Now, we need to find the center of mass. So for the center of mass, we will have a 1 over m. We will have a double integral of x times 1 plus 3x plus y dy dx. And these limits are going to be the same, 0 to 2 minus x and 0 to 1. And for y bar, it will be 1 over m, 0 to 1, and 0 to 2 minus 2x, y times 1 plus 3x plus y dy dx. Again, this one, completion of this, I'm leaving this as an extra credit stuff that you can email me. The next concept we have is the idea of moment of inertia. Moment of inertia is defined as there are three different kinds of moments you can have about an x-axis, which is given by y squared times density function, double integral, about the y-axis, which is x squared times the density function, and about the origin, which is x squared plus y squared times the density function. So if you look at the formula for the center of mass, right, x and y, it has x times. So it's kind of like the 0th moment because the power is 1. And when you do an x squared, that's like the first moment, which is the moment of inertia. Let's look at an example. Suppose there's a homogeneous disk with rho equals to rho, center at origin, radius a, find each of these. Homogeneous disk means that it's uniformly dense. So there are no distribution, there's no mass distribution, or there is a mass distribution, but it's not, it's uniform. It's a constant everywhere. So finding Ix would just be y squared rho dA, and because we're working with a circle of radius a, we can use polar coordinate. So this becomes r squared sine squared r dr d theta, 0 to a, 0 to 2 pi. So rho over 3 a cubed, then a sine, over 4 actually, because of the other r. So rho over 4 a to the 4 sine squared theta, 0 to 2 pi d theta. And sine squared theta, 0 to pi 2 theta, we have seen this. When you work this out, you end up with pi. So you get pi rho a to the 4 over 4. Same thing if you work with Iy, you end up with the same rho a to the 4 over 4. And if you find I naught, then this will just be x squared plus y squared, which means you have an r squared, because x squared plus y squared is r squared in polar. And you can work it this way, or you can make the observation that x squared plus y squared rho dA is double integral x squared rho dA plus double integral y squared rho dA, which means this is just the moment of inertia in the x-axis plus moment of inertia on the y-axis. So when you add them up, it's just going to be 1/2 pi rho a to the 4. The next one, which we will see not so much in much detail, is probability distribution. Distribution of probability satisfies this condition, which means that over negative infinity to infinity, when you integrate, when you add the area, it should come out to be 1. And when you're finding the probability of anything, it's actually an integral between the points A and B. And we also have something called joint density, which is when you have a pair of random variables x and y, then instead of single integral we have a double integral that comes into play. So a sample question could be something like, suppose there's a joint density function given by this f of xy is some constant times x plus 2y for x between 0 and 10, y between 0 and 10, 0 otherwise. Find this constant c and then find this probability. So first of all, to find the constant c, what we need to understand is that even though this is a joint density function, which means the total probability will require a double integral. And if I take the total probability over all possible things, this should come out to be 1. Right? And that's what's going to help us solve for c. So if I find the integral of c times x plus 2y dy dx, it is 0 everywhere else. It's only non-zero between 0 and 10 and 0 and 10. So this actually becomes 0 to 10 and 0 to 10. Now this is pretty straightforward. You have c xy. So bring the c out. Xy plus y squared. Y 0 to 10. Y 0 to 10. So c another 0 to 10. That's going to be a 10x plus 100 dx, which is c. 5x squared plus 100x from 0 to 10, which is c. 500 plus 1000. So what you end up is 1500 c equals 1. So for this to make sense, c has to be 1 over 1500. Now, to find the probability that x is less than 7 and y is greater than 2, what does that mean? X is less than 7 and y is greater than or equal to 2 would mean you have 1 over 1500 x plus 2y dy dx. Y is more than 2, so it goes from 0 to infinity, and x is less than 7, so negative infinity to 7. But everything outside of 10, the probability distribution is 0, so you don't have to really consider from negative infinity. You only have to go from 0 to 7 and from 2 to 10, x plus 2y dy dx. And if you complete this evaluation, you should get about 868 divided by 1500. Oh, that should be exact. It should come out to 868 over 1500. And that's it for this particular video. There will be further videos for the next topic in this particular sequence.